time, science is essential. Everywhere, all the time, science boosts your potential. Knowledge equals power. Don't waste another hour. You can do it. Anywhere, anytime.
This is a breaking news special report. Hello, I'm Drew Blankstein with a special science update. For the very latest in this still developing story, let's go to our reporter on the scene, Danielle Zaros.
Hi, this is Danielle Zaros with your latest beach report. I am sorry to say all these hurricanes and storms we've been having are causing a lot of beach erosion.
You know, in Florida, we hear a lot about this term, erosion. But what exactly does it mean?
Erosion is the movement of rock and soil that's been broken down by the process of weathering. It is often used with the term deposition. This is when particles are dropped in the erosion process. I'm Danielle Zaros with your latest beach report from the Weathering Channel.
Thank you, Danielle. But perhaps we should start at the beginning in order to better understand this process. If we took a slice out of the Earth, this is what it would look like. 3 distinct layers. The core, the mantle, and then a layer of solid rock called the crust. The core is the center layer. It's very hot. It has an outer core of liquid iron and an inner core of solid iron. Then there's the mantle. The layer closest to the core is very hot, gooey rock, while the upper part of the mantle is made of warm, solid rock. Above that is cooler solid rock. This thin layer is called the Earth's crust. We live on the surface of Earth called the crust. It's made of rock and it's a very small portion of the actual Earth, but it's a very important part. The Earth's surface is slowly but constantly changing all around us. We've just learned the Earth's crust is made of solid rock. Rocks. They may all look the same, but this investigative report will uncover the reality of rocks.
I'm Tyler Murray in the Weathering and Erosion Lab with a collection of rock samples. There are 3 categories of rocks. The categories are based on how the rocks are formed.
This is an igneous rock. It's formed when molten rock from beneath the surface of the Earth cools and hardens. Sedimentary rocks like this one are formed when layers of sediment including pebbles, sand, silt, and clay get squeezed and cemented together. This one was changed over time by pressure and heat to form a metamorphic rock.
Unbelievable! Just when you thought a rock was just a rock. It turns out we have a lot to learn. What we'll show you next will rock you. The formation and continual change of rocks over time is called the rock cycle.
Let's think back to our slice of Earth.
The Earth's crust is constantly being changed by weathering and erosion. Weathering and erosion shape our land. The process of weathering breaks down rocks over thousands of years, and erosion moves it all around. This process is usually very slow, but sometimes a natural disaster like a hurricane speeds it up.
How would the surface of the Earth look if, like the surface of the Moon, there was very little atmosphere or weather?
There are 2 types of weathering, physical weathering and chemical weathering.
Physical weathering of rock. Wow. It's wind, water, sun, and even the lowly worm. All of these elements of nature act upon solid rock. The water gets down into crevices and expands it. The sun expands it. The night air contracts it. The water washes gently on it, but always, always washing on it. The wind constantly blows on it. And finally, it gets weathered. So weathering of rock is when all of these components of nature come and they actually wear down the rock into small itty-bitty pieces called sediment.
What force could possibly be strong enough to turn solid rocks into sand and pebbles? It must be something incredibly powerful. It must be something huge. It must be a worm? This little worm is part of the physical weathering process called biological weathering, which is caused by plants, roots, insects, worms, and other animals that dig tunnels underground. Their persistent but gentle force eventually caused the rock to break down. Our investigative report also uncovered the fact that rain, wind, water, and frost are also types of physical weathering. When water seeps into tiny holes or pores in the rock, the minerals in the water form crystals. As these crystals grow, they exert a force that causes the rock to break down. This process is called crystalline weathering. Frost wedging happens when water seeps into the pores of a rock and then freezes. Since the water expands when it's frozen, it exerts a force which causes the rock to break apart.
Even the temperature can cause physical weathering. Temperature fluctuation happens in areas where there's a big difference between daytime and nighttime or seasonal temperature. When the temperature is cooler, particles in the rock shrink, but as the temperature warms, the particles expand. These forces of contraction and expansion cause the rock materials to loosen and crack.
What kinds of physical weathering happen where you live? There are different kinds of chemical weathering. Oxidation, hydrolysis, and carbonation are a few examples. Oxidation happens when oxygen combines with the elements in the rock. A common example of this process is rust.
This happens when oxygen combines with the metal iron. Hydrolysis happens when water mixes with the elements in the rock and forms a new substance. A common example that contains this new substance is China. The thing that makes China so special is that it's made from these fine particles. Carbonation occurs when carbon dioxide combines with the elements in the rock and changes it into something new. This process happened with the famous landmark. The Statue of Liberty is made of copper and was originally the color of a penny, but the carbon dioxide in rain chemically changed it into copper carbonate and turned it the blue-green color we see today. Other kinds of chemical weathering include solution and hydration. Solution occurs when rocks simply dissolve in water. A good example of solution weathering is cave formation in areas with a lot of limestone. Hydration occurs when water bonds to the minerals in the rock, causing it to expand. An example of this would be the mortar that is used to build buildings.
How do chemical weathering and physical weathering work together?
A very interesting investigative report indeed. Now, you might be wondering, what all this has to do with erosion? Let's find out. We all know that weathering must happen before erosion. There's physical weathering, which includes temperature fluctuation, frost wedging, biological weathering, and crystalline weathering. Then you have chemical weathering, which includes oxidation, hydrolysis, and carbonation. But then what? Weathering is just the breaking down of rock, that's the first step. But erosion is the movement of this material. Weathering breaks it down, erosion moves it around. But there are different kinds of erosion in different regions of the Earth. There's water, wind, glacial, and sea erosion. Let's start with water, which is the most powerful force in erosion. For more, let's go to our reporter in the field, Steven Sanchez.
Hi, Drew. I'm standing here on the edge of the Grand Canyon, and it is just breathtaking. The Grand Canyon is a great example of water erosion because it was carved out by the Colorado River. Water erosion isn't always this spectacular. It can be as simple as a river or a stream carrying soil from one point and depositing it somewhere else. You'll recall this is defined as deposition in the erosion process. We see this very clearly at river deltas. Rivers carry particles downstream and deposit them at various points.
Thanks, Steven. Let's go to Tyler Murray.
Hi, Drew. The power of wind erosion just blows me away. Literally. It happens when soil becomes dry and easily moved by the wind. This often occurs in desert areas. The dust and sand can cause lots of problems like damaged machinery and pollution to the environment, and poor visibility.
Thanks, Tyler. Now let's go to our ice expert, Samantha Santana.
Hi, Drew. Sure looks nice and warm in there.
Oh, it's toasty. Tell us about glacial erosion, Samantha.
Glaciers are moving bodies of ice. As the glacier moves, it picks up pieces of weathered material and then drops them off in piles along the way, and at the end, as it melts. Glaciers are wide bodies of moving ice that carve out wide U-shaped valleys, as compared to water erosion, with a narrow river which carves out a V-shaped valley.
Finally, let's go to our correspondent at the beach, Danielle Zaros.
Thanks, Drew. I'm here to talk to you about sea erosion, which is caused by the movement of the ocean and by the tides. Salts and other chemicals in the seawater can cause rocks to weather and weaken, and then wash up on shore. Waves can also cause erosion to rocks and sand near the shore, causing them to take on unusual shapes.
So, let's see what we have. Water, wind, glacial, and sea erosion. Thanks, everyone. That's all we had today for the erosion report. Whew. Boy, that was a lot of work. I'm exhausted. What kinds of human activities might cause erosion? Well, that's it for today. This has been a special science update on weathering and erosion. And remember, anytime, anywhere, science is everywhere. Now, stay tuned for your favorite game show, Whether or Not.
It's time to play everyone's favorite game show, Whether or Not, where viewers at home and in the classroom demonstrate whether or not they can remember their newly acquired knowledge of weathering and erosion. Hello and welcome. I'm your charming host, Clay Feldspar. Today I'll ask you a series of questions, and whoever answers the most correctly will win. Don, tell them what they'll win.
A brand new set of rocks. These beauties are from all three rock categories. First, there's an igneous rock, which is formed when molten rock from beneath the surface of the earth cools and hardens. Then, a sedimentary rock. Rocks like this are formed when layers of sediment, including pebbles, sand, silt, and clay, get squeezed and cemented together. And last but not least, metamorphic rocks, which are rocks that are changed over time by pressure and heat.
Wow, are you ready? Here's our first question. What shapes the Earth's surface? That's right. The Earth's surface is constantly being shaped and changed by weathering and erosion. Next question. The process of breaking down rocks by force is A, angry weathering, B, physical weathering, C, weathering, D, psychic weathering. You've been doing great so far. Let's see how you did on this one. The answer is B, physical weathering. Let's see if you can name all the types of physical weathering and their definitions. Do you remember them all? There's biological weathering, which is caused by worms, plants, and bugs. Then there's crystalline weathering. That happens when the water seeps into the rocks. The minerals in the water form crystals that grow and force the rock to break down. Then there's frost wedging. Water seeps into rocks, then freezes and expands, forcing the rock to break apart. And finally, temperature fluctuation. Particles in rocks expand and contract from big changes in temperature and weaken the rock. Next question. Chemical weathering actually changes the properties of rock. True or false? That's true. Ooh, that's the sound of our bonus round. Moving on, we've got a lot to cover. Erosion is the process of breaking down rocks. True or false? I can't fool you. It's false. Weathering breaks down rocks, and erosion moves it around. I just can't believe how much you remembered. How about another? Can you tell which form of erosion is represented by each image? Water, wind, glacial, sea. Ooh, that was tricky, but hang in there. Next question. Oxidation, hydrolysis, and carbonation are all examples of what? Right, chemical weathering. Oh, I'm sorry. Time's up. You've been absolutely amazing today. Or should I say, you rock. Speaking of rocks, feel free to claim your prize anytime, anywhere, 'cause science is everywhere. Thanks for joining us on Whether or Not. I'm Clay Feldspar. Rock on.
Activity 1. Finding weathering and erosion in your own backyard. Purpose. This activity will allow students to observe examples of weathering and erosion in their environment. Time, 30 minutes. Materials. Activity 1 worksheet from Learning Village. Pencil. Clipboards or hard surface to write on. Outdoor space. What to do? Step 1. Students will work in pairs. Give each pair an Activity 1 worksheet and pencil to record their observations. Step 2. Take students outside and ask them to find examples of weathering and erosion. A. Students should look around for cracked cement and plants growing through cracks. B. Check where water drips off buildings. C. Look for rocks, statues, and buildings. D. Look for anything that has been changed or altered by weather, wind or rain, or gravity. Step 3. Have students record their observations on the Activity 1 worksheet. Have them describe what they see and how it might have changed or been formed over time. Step 4. Groups should find at least 4 examples of weathering or erosion. Activity 3. Soil Ingredients Activity. Purpose. This activity will allow students to observe the components of soil and compare soil samples from different locations. Time. Setup, 30 minutes. Observe, 1 day. Materials. 3 large jars or empty soda bottles. You'll need this for each group. Funnel, 3 different soil samples, enough to fill each jar halfway. Pencil, paper, ruler or measuring tape, water, soil observation chart from Learning Village. There's a regular or advanced worksheet. What to do? Step 1. Collect 3 soil samples. Find soils that look and feel different. Students may collect their own samples if desired. Step 2. Group the students in threes. Observe and record the color and texture of each type of soil on the soil observation chart. Fill in the location you found each soil sample. Step 3. Make predictions on which sample will have the largest percentage of each soil component. Step 4. Label the 3 jars, 1, 2, and 3. Then fill each jar halfway with a different soil sample. Step 5. Add water to each jar until it is about 3/4 full. Step 6. Shake the jar vigorously and set aside for the night. Make sure that there is no soil clumped at the bottom. Layers will begin settling within 30 minutes, but for the best results, leave overnight. Step 7. Check soil samples the following day. Measure and record the height of each layer. Step 8. Determine which layer is organic material, sand, silt, or clay. Step 9. If you're using the advanced worksheet, calculate the percentages of organic material, sand, silt, and clay in each sample. Activity 4. Candy in a rock. Purpose. This activity will allow students to observe crystals growing slowly using rock candy as a demonstration. Students may journal their observations. Time. Setup 45 minutes. Observe 10 days. Materials. Up to 700 milliliters of sugar, 250 milliliters of water, hot plate or microwave, string, small clean metal paper clip, washer, nail, or other weight, pencil, glass jar or cup, and a wooden spoon. What to do? Step 1. Boil the water using hot plate or microwave. Step 2. When the water is boiling, carefully pour it into the glass jar, leaving a bit of room at the top. Step 3. Pour the sugar into the jar, a small bit at a time, mixing to make sure it is completely dissolved. Step 4. Continue until the water is saturated. Saturated means that no more sugar will dissolve into the water. The solution contains as much of the solid substance as it can hold. A few sugar crystals might start to settle at the bottom of the jar. Stop adding sugar at this point. A saturated solution will crystallize faster. Step 5. Tie one end of the string around the pencil. Tie the washer, nut, or bolt to the other end of the string so it will hang down into the water solution. Step 6. Carefully dip the string once into the water and sugar solution. Step 7. Allow the string to dry overnight. This will form seed crystals that will make the crystal growing process faster. Step 8. The next day, place the string into the water and sugar solution, using the pencil to keep the string from falling into the glass. Step 9. Allow the glass to sit for 10 days. Cover it loosely with a cloth or napkin. This will prevent dust or bugs from falling into the glass and also allow slow evaporation, making the solution even more concentrated. Do not disturb the glass since movement will affect crystal growth. After several days, look at the glass. Crystals should be forming on the string. Check the glass after each day in order to see the crystals growing. Step 11. Once the crystals have gotten big enough, pull the string out and examine. A special note: teachers should handle the boiling water, being careful that students do not burn themselves. Activity 5. Chemical weathering. This activity can be done as a demonstration or as a lab in which the students perform the experiments themselves. Students may journal their observations. Time. Setup 30 minutes. Observe 1 week. Materials per group or per demonstration. Steel wool without soap. 5 milliliters of water. 50 milliliters of vinegar. A penny, antacid tablet, carbonates such as small pieces of marble, seashell, or chalk. 6 beakers or clear plastic cups. What to do? Reaction 1. Step 1. Examine the antacid tablet. Observe its properties. Ask students to describe it. Explain that it is made of sodium bicarbonate, much like the carbonate found in many of the rocks we have been studying. Step 2. Drop the tablet into a beaker with about 10 milliliters of vinegar to represent the long-term effects of slightly acidic rain. Step 3. Repeat steps 1 and 2 with other carbonates, such as marble, seashell, or chalk. Encourage students to observe carefully, as some reactions may be very subtle. Step 4. Return to observe the carbonates after setting up reactions 2 and 3. Step 5. Observe the transformations each day over a period of a week. Reaction 2. Step 1. Cut a piece of steel wool about the size of a lemon. Observe its properties. Ask students to describe it. Explain that it contains a metal called iron. Save the other piece of steel wool for comparison at the end of the experiment. Step 2. Place it in a beaker. Moisten it with about 5 milliliters of water. Step 3. Observe the transformation each day over a period of a week. Compare the original steel wool with the piece in contact with water. Reaction 3. Step 1. Examine the penny. Observe its properties. Scratch the surface of the penny with something hard, like a nail. Ask students to describe it. Explain that it is made of metal called copper, like in the Statue of Liberty. Step 2. Place a penny on a paper towel in the beaker. Put 2 or 3 drops of vinegar on the penny. Step 3. Observe the transformation each day over a period of a week. Activity 6. Kinds of erosion. Purpose. This activity will demonstrate many different kinds of erosion. The experiments can be done as a demonstration or as a lab in which the students perform the experiments themselves. Time: 1 hour. Materials: 6-sided pencil, nail file, sponge, bar of soap, sink with running water, 2 soils of different colors, enough to cover 1/3 of the baking tray, jar with holes punched in lid, 2 to 3 textbooks, water. What to do? Erosion example 1, abrasion. Step 1. Take a 6-sided pencil and rub the side with a nail file. Step 2. Observe. Explain that small pieces of the paint and wood are being rubbed off. Erosion example 2, water erosion. Step 1. Place the bar of soap on top of a sponge and place it right below the faucet of a sink. Step 2. Run the water and watch what happens to the soap. Step 3. Observe the middle of the soap. Erosion example 3, river erosion. Step 1. Take one of the baking pans. Prop up one end with 2 or 3 textbooks to make a nice slope. Step 2. Cover the upper third of the baking pan with one kind of soil, perhaps dark topsoil. Layer the other soil, perhaps light-colored sand, on top. Step 3. Fill the jar with holes in the lid with water. Pour water over the top of the soil until you see a river form, flow down the slope, and create a delta at the bottom of the pan. Step 4. Observe. Explain that this is much like a river. Water flows down a slope, eventually forming a channel. As soil is eroded down the slope, it is deposited at the bottom to form a river delta. Erosion example 4, wind erosion. Step 1. Using the hole punch, make several holes in the piece of paper, keeping the circles that are made. Step 2. Place about half the punched holes in the baking pan. Take the other half and make them slightly damp using water. Step 3. Place the damp, punched holes in the pan with the dry ones. Step 4. Have the students blow on the punched holes. Observe the result.